Good morning, students. Today, in this session, I am going to discuss about the linear differential equation of the first order. And after the session is over, you must view and subscribe the channel. Don't forget, okay? Uh, just see it, okay? Uh, Linear differential equation. Linear differential equation. Actually, an equation is in the form of dy by dx plus py is equal to q is known as linear differential equation of first order. Okay, first order. Okay, where p and q are the functions of x alone, function of x alone, function of x alone, or constants. An equation is in the form of dy by dx plus py is equal to q is known as linear differential equation of first order, where p and q are the function of x alone, or constant. Okay. Then to get the general solution, then to get the general to get the solution actually solution to get the solution we have to multiply both sides by integrating factor IF. We have to multiply both sides by we have to multiply both sides of the differential equation of the diff equation with integrating factor IF. An equation is in the form of dy by dx plus py is equal to q is known as the linear differential equation of the first order, where p and q are the functions of x alone or constant. Then to get the solution, we have to multiply both sides of the differential equation with integrating factor, that is shortly denoted as IF. Okay, clear? Then what we have here, the integrating factor is the integrating factor is the IF is e to the power p dx. Clear? IF is p dx. Okay. IF is p dx. Clear? We shall multiply this e to the power p dx. We shall multiply both sides of this differential equation with integrating factor. The integrating factor with integrating factor this. Okay. So you just see an equation is in the form of dy by dx plus py is equal to q is known as the linear differential equation of the first order, where p and q are the functions of x alone or constant. Then to get the solution, we have to multiply both sides of the differential equation with the integrating factor if. The integrating factor is e to the power p dx. Okay, and you just see when we shall multiply. Actually, we have to multiply. We have to multiply. We have to multiply. We have to multiply both sides of the differential equation. Both sides of the differential equation differential equation with e to the power integration p dx. Okay, this is the integrating factor. We have to multiply both sides of the differential equation with e to the power p dx. Okay, you just see here. Now I am rubbing this part. As we have taken this, fine. This part I am rubbing. So you just see. Dy by dx plus py is equal to q. Okay, so e to the dy by dx into e to the power p dx plus py into e to the power p dx, that is equal to q e to the power p dx. Okay, fine. So this multiplied both sides with integrating factor. Okay, here what we have done, we have just multiplied both sides by integrating factor this. Okay, one line I want to add here. Multiply both sides of equation with IF, integrating factor e to the power p dx. This multiply both sides of equation with integrating factor e to the power p dx. Okay, fine. And after that, this operation is done. Dy by dx e to the power p dx plus py e to the power p dx is equal to q e to the power p dx. Okay, so this we can write here ddx of y e to the power p dx. Okay, and fine. and this is q e to the power, this is actually q, fine, q, this is q e to the power p dx. Okay, so what will happen here, d y e to the power p dx. Okay, that is equal to q e to the power p dx, and this becomes dx. Okay, now integrating both sides, we shall integrate here both sides. Okay, so d and derivative and integration are integration are inverse to each other. So derivative and integration are inverse to each other. So that will be here y e to the power p dx, that is equal to q e to the power p dx, and this is dx. Okay, fine. So or y is equal to if we shall divide both sides of this equation by e to the power integration p dx, then we have here actually e to the power minus of p dx, and this bracket is used here. Okay, this is, as I have integrated here in the left hand side, then I will write here c. This is the constant of integration. Okay, because I have integrated here. Okay, actually the process of integration has been done here, so that is why I have to put here constant of integration here. So here it becomes what, q e to the power p dx. Okay, and the actually integration of entire function plus c. Clear? Y is equal to e to the power minus p dx into integration q e to the power p dx, and integration of entire function plus c. Actually here constant is not used to written because it is in the place of exponent or power. So we shall not go to write the constant here, constant of integration here. Okay, so you just there is the general solution. This is the general solution. Is the solution. Okay, fine. Okay, is the solution. Done.